Okay, so I want to give you a couple problems to do on your own, but before we do that, well, actually, let me see. I'm just looking at my examples. So, let me give you those problems, and then maybe I'll go over one of them. Okay, so for practice, so the main point here is to graph it, right? Is to be able to graph it, and then get your domain and range, and also those intercepts, right? Those intercepts are quite interesting. They involve quite a bit of thinking. So this one is quite similar to what we just did. So here, in addition to graph and those intercepts, try to do those evaluations. So the same numbers as in our first example. So f of -2, f of 0, and f of 2. Okay, the second one is f of x. And here I have just two functions. Maybe I'll go over this one. This one is quite interesting, maybe. I don't know, maybe the first one. And the third one is, or maybe the third one is the most interesting. So this one is x plus 1, x squared, and conditions are if x is less than 0. Okay, so for all of those, get the domain, and then range. Yeah, we forgot to do range here, but I'll do it in a moment. Domain, range, B intercepts, and C graph. You don't need to start with domain, right? You can start with graph and see what is happening, but I want you to figure it out algebraically. Okay, so just getting the intercepts from the graph is not good enough. Okay, yeah, range for this one. Okay, for our second example. So range, I hope you can see this easily. Let me just look at domain first. Okay, so we decided domain was from -3, right, which was right there, to infinity, and yeah, that's right. If you projected all the points onto the x-axis, that's what you would get, right? So domain from -3, and then it seems like maybe there's a break, but that break in the function is filled by this part of the function, this point, right? And then the function goes up, but it also goes to the right, right? So that's why domain was from -3 to positive infinity. Okay, so range is a little different, right? Range goes from here, from -1, and I need a parenthesis there. So from -1 all the way to positive infinity. And again, right, we have something that looks maybe like a break over here, but that break is filled up by this point in the function, in this green function. Okay, so I said that we would go over one of the functions here, and I'm just looking. This, right, we just did it. Maybe I'll go over this third one. Okay, the third function. So let's start. Let's start with domain, right? So for domain, for that number 3, looks like everything is covered, right? So this, for x's, for negative x's, that's going to be covered by this function, and positive x is going to be covered by this function, right? And there's no no breaks, no the function is not, the x's are not restricted in any way. Okay, so the numbers I put in for x's, so all real numbers for domain. So for range, let's wait and see how the function looks like. So let's do those intercepts. So let's start with x-intercepts this time. So for x-intercept, y needs to be 0. Okay, so let's start with the first one. So I have, right, y equals x plus 1. So I plug in that 0 in here. 0 equals x plus 1. And then x equals negative 1. So that seems like a, right, like a intercept that actually exists, right? Because x is negative 1, and this function works for x's that are less than 0. So my intercept will be negative 1 and 0. Okay. So let's check the other function for x-intercepts. So let's do the green. So the other function is y equals x squared. And I need to plug in 0 for y. So 0 equals x squared. And if we solve it, we get x equals 0. And again, this looks like a perfectly fine x-intercept. And it's going to be 0, 0, right? So for x equals 0, y is 0, and 0 works, right, for this function, because I'm talking about the green one, and that's that this function is defined for 0. Okay, so let's do the same exercise for y-intercept. Now there's just going to be 1, maybe. So that will be y-intercept. So for y-intercept, x will be 0. So my red function was what? Y equals x plus 1. So we get y equals 0 plus 1. So y equals 1. Okay, so that's our okay. I'm just looking at those. So that was our first function. Well, unfortunately, right, this function is not defined for 0, right? So I cannot even be checking it. So no intercept, no y-intercept, because x equals 0, not in domain. Okay, so let's check the other one. Let's check the green one. So this one is y equals x squared. And I need to plug in 0. So y equals 0. And we get intercept, y-intercept 0, 0. right? So x is 0, y we found is also 0. Okay, so let's try to graph it and see how it looks. Okay, so we have two functions. One is just a straight line, x plus 1. So let's have this as our, no, maybe this is our 1. So first function is x plus 1. Okay, I'm just going to make it open circle because I don't know what's happening there. And now drawing it lightly. And then the other function is x squared. So for 1 I get 1, for 2 I get 4, right? Same thing on this side. Right, it's just a parabola. Okay. So now how those functions are defined. So the first one, the red one, is defined for x is less than 0. So actually, yeah, I was right, right? I left that open. And then this part of the graph belongs to the actual function. So this is y equals x plus 1. Okay, and then the second one, the green one, actually starts here. So it's defined for x equals 0, and then goes this way. Okay, so this is the second one, second function, y equals x squared.